Now let us consider what are the constraints in SQL. Constraints are rules that the data in the database must follow to ensure that only correct values are accepted in specified columns. The values are verified whenever a row is to be inserted, updated, or deleted. Constraints prevent the deletion of a table if there are dependencies from other tables. In other words, no foreign keys. Assigning names to constraints helps with their identification. Otherwise, if we do not assign names to our constraints, the Oracle server assigns names using the following format: sys_cn. The following are the types of constraint in SQL. First is the primary key, to specify the primary key in a table. Next is the foreign key, to specify the foreign key in a table. Next is the check. The check defines a condition that a column must satisfy. Unique is a constraint that requires that no two rows in a table must have the same values in a specified column. And lastly, we have seen before the not null, which ensures that a column contains no null values. We can define constraints either at the column level or at the table level. At the column level, we are going to specify the constraint right after our data type. At the table level, we will define our constraint at the very end of our table definition. The following is an example of the column level constraint and table level constraint. For the column level constraint, we can see that the author ID is our primary key. If we're going to do the table level constraint, we can see that we specify the keyword constraint, the name of our constraint, in which case we specify it to be book author underscore ISBN underscore author ID underscore PK for primary key, and then the primary key keyword, and then the columns that are going to be the primary key. In this case, ISBN and author ID are the primary keys for our book author table. Next is the foreign key constraint. If we can recall, a foreign key is defined in the child table. The table containing the reference column is the primary key column in the parent table. The foreign key condition in our definition in child table is as follows. We have the keyword foreign key, which defines the columns in the child table, references, which identifies the name of the parent table and the columns to be referenced by that foreign key, and we can either add onDelete cascade or onDelete set null afterwards. If we add onDelete cascade, we mean that when a row in the parent table is deleted, the dependent rows in the child table are also deleted. But if we have onDelete set null, when a particular row in the parent table is deleted, the corresponding foreign key values in the child table are only set to null. The check constraint defines a condition that must be satisfied by every row of our column. A single column may have several check constraints depending on our conditions. An example of a check condition is that, for example, if our column is gender, we can specify that the values that we can get in our column is only M and F. Take note that the not null constraint is a special case of the check constraint. We can also add constraints after the table is created. With the alter table statements, we can either add or drop constraints or enable and disable constraints. We can see in our slide the syntax for the add or drop constraints and the enable or disable constraints. For example, if you would like to add a primary key to our promotion table, this is how we're going to do it. We start with the alter table keyword, the name of our table, add constraint, the name of our constraint, and then the name of the type of constraint that we're going to add, which is primary key, and then the column to which we're adding the primary key to. If we would like to add a foreign key constraint to the orders table, here is how we're going to do it. We start with the alter table keyword, the name of our child table, in this case the orders table, the add constraint keyword, the name of our constraint, the foreign key keyword, the column name in the orders table that we would like to add the constraint to, the references keyword, the name of the table or the parent table that we would like to reference to with our foreign key, and the primary key in that table. Here are some examples of how to add a few more constraints. In our publisher table, we are adding a unique constraint for the column name. It means that no two publishers can have the same name. If you try to add another publisher with the same name that is already existing in our table, Oracle or SQL will not allow that. For the books table, we're adding a constraint with the pub ID. The constraint is not null, meaning we're not allowing records to be inserted into books without specifying the publication ID. And lastly, for the orders table, we're adding a check constraint for the orders table wherein we are checking if the order date is less than or equal to the ship date. If the ship date happens to be greater than or happens to be occurring at a later time than the order date, then the insertion to our orders table will not allow that. The following is an example of adding multiple constraints on a single column. But first, let us check the constraint in the AM first and the AM last. As we can see, we have specified them to be not null. Next, let's take a look at the AM salary. As we can see, we have two constraints for the AM sal. First, it should be not null, and then next, we should check if it is greater than 0. And then lastly, we have the region. For the region, we have the constraint, check, and the value for the region should be in the following. It can only be north, northwest, northeast, south, southeast, southwest, west, or east. And finally, we're assigning the primary key to our AM ID. If we no longer need the constraint, we can also drop them. The syntax for dropping a constraint is as follows. We have the alter table keyword, the name of the table, drop constraint, and the name of the constraint that we're going to drop. We can also temporarily disable a constraint without dropping it completely by using the alter table statement as well. It is as follows. The alter keyword, the name of our table, the keyword disable constraint, and the name of the constraint that we would like to disable. Take note that the cascade option disables dependent integrity constraints. And disabling a unique or primary key constraint also removes the index that was automatically created for such columns. In the same way, we can enable a constraint using the enable constraint keyword. Take note that all existing data in the table must comply with the constraint. If we enable a unique key or a primary key constraint, a unique or primary key index is recreated automatically. The cascade constraints clause could be used along with the drop column clause. The cascade constraints clause drops all constraints defined on the drop columns. If we are dropping some columns that violate some of the constraints, we can have the following errors. For example, if we are trying to drop a column that is being referenced as a parent key from our foreign key, then we will have a cannot drop parent key column. Also, if we are dropping a column that is referenced in a multi-column constraint, we will also have the following error. That is the beauty of cascading constraints. Because if we have some constraints that are being violated, the FK and the multi-column constraints that we have seen in the previous slide are dropped with the cascading option. So the following statement will work. Alter table, test, drop A, cascade constraints. So all of the constraints that are being affected by dropping the column A are also being considered. Alternatively, if the other columns used by the constraints defined on the drop column are also dropped within the same statement, then the cascade constraints is not necessary.
In summary, we are able to discuss the following. We have learned how to create tables, insert data, delete rows of data from our tables, discuss what null values are in SQL, and discuss the different types of constraints that are available in SQL.